Module 2, Software Defined Data Center. With Module 2, it is very important that you have the basic understanding of the following concepts and best practices: virtualization, VMware ESXi, and the virtual machine, the fundamental vSphere components and how vSphere can be used in a software-defined data center, and how VMware vSphere Client and VMware vSphere Web Client are used to administer and manage vSphere environments. Lesson 1, Introduction to Software Defined Data Center. By the end of this lesson, you should be able to meet the following objectives: compare and contrast physical and virtual architectures, describe the benefits of using virtual machines, describe how vSphere interacts with CPUs, memory, networks, and storage, and describe how vSphere fits into the cloud and the software-defined data center. In this slide, we're going to look at how managing and maintaining a physical data center is time-consuming and inefficient. Traditionally, over time, we've looked at how data centers have been set up, and they've been set up with operating system and software on a physical computer. Large physical infrastructures like that pose several challenges in data centers. This slide that you're seeing here is not flexible and can be very inefficient. The planning and cost of proper infrastructure, like the square footage, the rack space, the power, cooling, and such things like that, are challenges that IT staff must address. You also notice in this model that a one-to-one relationship exists between the physical computer and the software running on it. And the physical computer and software is basically all this you see here in this physical environment. This relationship leaves most computers in this physical server data center here vastly underutilized. And I would say anywhere from 5 to 10% of the physical server capacity is only in use. So if you take that and you look at the cost of space, power, and cooling, that can be expensive. Provisioning physical servers is a time-consuming process also. In a non-virtualized environment like this, time must be allotted to procure the new hardware placed in the data center, install the OS, put patches on the OS, and so forth. Installing and configuring the required applications can take weeks. This process also includes tasks such as configuring firewalls, enabling switch ports, and provisioning storage. In this slide, you'll notice how virtualization enables you to run more workloads on a single server by consolidating the environment so that your applications run on the virtual machines. And with that being said, the virtualization technology today changes the way servers are provisioned. You don't have to wait for the hardware to be procured or cabling to be installed. Virtual machine provision is performed through a GUI. Basically, in contrast to the long process of deploying physical servers, virtual machines now can be deployed in a matter of minutes instead of hours or possibly days. In this slide, we're going to discuss what is a virtual machine. A virtual machine is a software computer, like a physical computer, that runs on an operating system and other applications. The virtual machine components include the operating system such as the OS, the VMware tools, the virtual resources like the CPU, the memory, the network adapters, the disk controllers, or the parallel and serial ports. Now, with all this being said, the virtual machine, it includes these specific configuration files and is backed by the physical resources of a host. Every virtual machine has a virtual device that provides the same functionality of physical hardware but are more portable, secure, and easier to manage. Virtual machines typically have an operating system, VMware tools, and virtual resources and hardware that you manage much like the same way you would a physical computer or a server. VMware tools is a suite of utilities that you install on the OS of the virtual machine, and it improves the performance and the management of the virtual machine. As you'll notice here, you can see the benefits of using a virtual machine. You've got your physical machines to the left in this slide, and you got your virtual machines to the right. Now, if you'll notice, the physical machines could be difficult to relocate, difficult to manage, and it has limitations. But using a VM with VMware, it's easy to relocate, it's easy to manage, it provides the ability to support older legacy applications, and enables all of your servers to be consolidated. So when you look at this as a whole, multiple virtual machines are isolated from one computer. You can have a database server and an email server running on the same physical computer, and also the isolation between the VMs means that software dependency conflicts are not an issue. As a result of your virtual machine isolation, if a guest OS or a guest operating system is running, a virtual machine fails, the other virtual machine on the same host are unaffected and continue to run. A guest operating system failure has no effect on the ability of users to access the virtual machines, the ability of operational virtual machines to access the resources, and the performance of other virtual machines. But if you look at this, virtual machines enable you to consolidate your physical servers and make more efficient use of your hardware. They rapidly and consistently provision virtual machines. You can use live migration, fault tolerance, high availability, and you can increase the uptime and reduce recovery time when failures happen. You can also have set up with your security options that are not in the physical infrastructure, such as using VMware vShield, VMware vCloud, networking, and security applications to secure your perimeter and your endpoints. But also make note of this, with VMs you can support older legacy applications and new operating systems on newer hardware when maintenance contracts on the existing hardware expire. Your physical architecture and your virtual architecture, basically your virtualization, is a technology that decouples your physical hardware from a computer OS and provides a solution to many of the problems that maybe your IT staff would face either presently or in the future. So this slide right here, it basically shows you the differences between a virtualized and a non-virtualized host. In the traditional architecture, which is the physical architecture, the operating system interacts directly with the installed hardware. It schedules the processes it runs, allocates the memory, sends and receives the data on the network cards, and it reads from and writes to your attached storage devices. But if you make the comparison here, the virtualized host interacts with installed hardware through a thin layer of software, which is basically your virtualization layer or the hypervisor. The hypervisor provides you a physical hardware resources dynamically to the virtual machines as needed to support the operation of the VM. The hypervisor also enables VMs to operate with a degree of independence, which means they operate single-handedly from the underlying physical hardware. So if you look at an example of this, a VM can be moved from one physical host to another, and its virtual disk can be moved from one storage type to another without affecting the functioning of the VM. With virtualization, you can run multiple virtual machines on a single host. Each VM shares the resources of that one physical computer across multiple environments. Each VM shares access to CPUs and are scheduled to run by the hypervisor.
And also, another big thing here is VMs are assigned their own region of memory to use and share access to the physical NICs and the disk controllers. Different virtual machines can run different operating systems and applications on the same physical computer, which going back, then once you're running these same operating system applications, you're virtualizing that whole environment and getting more use. You're getting better use out of your equipment you have on site. With multiple virtual machines run on an ESXi host, each VM is allocated a portion of the physical resources. The hypervisor schedules the VMs like a traditional OS and allocates the memory for the scheduled applications. These VMs run on various CPUs, like your applications. They use network disk bandwidth. But however, understand that VMs are managed with elaborate control mechanism to manage basically manage how much access is available for each VM. And with the default resource allocation settings, all VMs associated on the same ESXi host receive an equal share of available resources also. Right here, you look at your CPU virtualization, and the in this physical environment, you'll notice that the OS assumes the ownership of all the physical CPUs in the system. The CPU virtualization, it basically focuses on performance and runs directly on any available CPUs in that architecture. CPU virtualization is not an emulation, y'all. The software emulator enables programs to run on a computer system other than the one for which they're originally written. Emulation provides portability, but it could possibly have a negative effect on performance also. CPU virtualization is not an emulation because the supported guest OSs are those designed for 64-bit processors. The hypervisor allows the OS to run natively on the host physical 64-bit processors. When many virtual machines or your VMs are running on an ESXi host, those VMs may compete for your CPU resources. When they start competing for these resources, the ESXi host basically time slices the physical processors across all the VMs, so each virtual machine running as if it had its own specified number of virtual processes. So basically it tries to equal out the processes to take the load off of one certain VM. In this slide, we're going to discuss the physical and virtualized host memory usage. Basically what you're looking at here, but once again, is your physical architecture and your virtual architecture. In this physical environment, the OS assumes the ownership of all the physical memory in the system. If you look at the virtual architecture, that memory virtualization emphasizes performance and runs directly on any available RAM. So basically, when an application starts, it uses the interfaces provided by the OS to allocate or release virtual memory pages during the execution. This virtual memory technique is basically, it's old and outdated, and that becomes an issue, or not really an issue, but you notice it's part of the general purpose operating systems in your physical architecture right here. Your virtual memory enables OSs to present more memory to applications than they physically have access to, and almost all modern processes have hardware to support that. Your VM, your virtual memory, creates a uniform virtual address space for applications and enables the operating system and hardware to handle the address translation between the virtual address space and the physical address space. This technique also basically it adapts to the execution environment to support large address spaces such as process protections, your file mapping, and swapping in modern computer systems. In your virtual environment, which we're going to discuss right here, the VM virtualization layer, it creates a contiguous addressable memory space for the VM when it is started. So basically, you got this memory space. The memory space, or the memory space you see right here, is right here. So that memory space allocated is configured when the VM is created and has the same properties as the virtual address space. This configuration enables the hypervisor to run multiple VMs simultaneously, which you look right here, you got 1, 2, 3 VMs, protecting the memory of each VM being accessed by these right here as a whole. On your physical and virtual networking side, the virtual Ethernet adapters and the virtual switches are key virtual networking components. This is critical that these are set up correctly and making sure they are functioning properly to make sure your access between all the VMs are going to communicate correctly. So a VM can be configured with one or more virtual Ethernet adapters. Virtual switches enable the VMs on the same ESXi host to communicate with one another by using the same protocols that are used over by physical switches without the need for additional hardware. These virtual switches, which are basically here, they support your VLANs that are compatible with your standard VLAN implementations from other networking equipment vendors, such as your Cisco. Cisco's a big one. With the VMware virtual networking, you can link local VMs together and link local virtual machines to external network through a virtual switch. A virtual switch, like a physical Ethernet switch, it forwards the frames at the data link layer. The SXI host must or may contain multiple virtual switches, meaning that you can have more than one virtual machine or virtual switch on that ESXi host. The virtual switch then connects to the external network through the outbound Ethernet adapters called VM NICs. Now, the virtual switch is capable of binding multiple VM NICs together in a manner which, much like NIC teaming on the traditional server, it offers a greater availability and bandwidth to the VMs using this virtual switch. These virtual switches are similar to the modern physical Ethernet switches in many ways. And if you look at the physical switch, each virtual switch is isolated and has its own forwarding table. So every destination to the switch looks up can match only ports on the same virtual switch where the frame originated. Your virtual switches also support VLAN segmentation at the port level. And basically they do this so that each port could be configured as an access or a trunk port, providing access to the single or your multiple VLANs, depending on how you got your organization set up. All right, let's look right here at this physical architecture a second. And let me say this, unlike these physical switches, virtual switches do not require STP, or basically your spanning tree protocol, because their single-tier networking topology is enforced at that level. Multiple virtual switches cannot be interconnected, and network traffic cannot flow directly from one virtual switch to another virtual switch on the same host. Your virtual switches provide all the ports that you need in one switch. Your virtual switches do not need to be cascaded because virtual machines do not share, basically, they don't share your physical Ethernet adapters, and the leaks do not occur between these virtual switches. Here we're going to discuss your physical file system and your virtual machine file system. Your virtual machine file system enables a distributed storage architecture allowing multiple ESXi hosts to read and write to your shared storage concurrently, or basically at the same time. Right here you'll notice you have your SAN, your virtual machine file system, and what that does, it allows you to write back all of that information here on multiple hosts to this one one shared storage here. Now, VMS does multiple things here. It's designed for and constructed for your virtualized environment. It uses distributed journaling of its file system metadata, and it changes it to enable fast and resilient recovery in the event of hardware failure. It increases resource utilization by providing multiple VMs with shared access to consolidated pool of clustered storages. It uses a foundation of distributed infrastructure services such as live migration of virtual machines and virtual machine files. It has dynamically balanced workloads across available computed resources, and it automates the restart of virtual machines and fault tolerance. Your VMFS provides an interface to your storage resources so that several storage protocols such as your fiber channel over Ethernet, and your iSCSI can be used to access data stores on which VMs can reside. When you look at these distributed locking, well, let me go back here. The dynamic growth of a VMFS data store through aggregation of storage resources and your dynamic expansion of a VMFS data store enables you to increase a shared storage resource pool with no downtime. So with the distributed locking methods, your virtual machine file system, it forges a link between the virtual machine and the underlying storage resources in a way that no other clustered file system can equal. This has the unique capabilities of the VMFS and enables the virtual machines to join the cluster seamlessly with no management overhead. Virtual machine files also provide encapsulation of the entire virtual machine so that your VMFS can easily become part of a business continuity or a disaster recovery solution. So you see right here you got 3 virtual machines running on a shared data store. All these right here, as you see, they're going to share those resources, and that's basically where your directories are on the virtual machine file system or your NFS data store. In a software-defined data center, all the infrastructure is virtualized, and the control of the data center is entirely automated by software. So if you look at it being totally automated by software, the software-defined virtual data center is deployed with isolated computing, storage, networking, and security resources, which makes it faster than the traditional hardware-based data center. The software-defined data center can include your virtualized infrastructure, your policy-based management and automation, and can have your hybrid cloud services such as your VMware vCloud Air. Your VMware vSphere provides features such as hardware abstraction, network virtualization, and resource pooling, and these features are critical for the success of the software data center deployment. So right here you got your cloud automation, got your operations, and right here you see you've got your whole suite of your VMware and vCloud Air data center partners, which are here, your public clouds. In the previous slide, we discussed basically some of your cloud computing. Here we're going to see how that fits in to how vSphere fits into cloud computing. Cloud computing is a model for enabling ubiquitous, convenient, and on-demand network accesses to a shared pool of resources. So basically, your examples of this are your networks, your servers, your storage, your applications, and your services can rapidly be provisioned and released with minimal management effort or little service provider interaction, meaning less IT staff, less resources for your IT staff to manage it. Your vSphere is the foundation of the technology that enables shared and configurable resource pools. The vSphere abstracts the physical resources of the data center to separate the workload from the physical hardware. VMware vCloud Air is basically it's new. and it enables you to abstract the VM resources or the virtual resources managed by the vSphere to easily allocate them to the resource consumers in the form of secure, high-performance virtual data centers, which can offer multiple tiers of service and performance. A software user interface can provide the framework for managing and maintaining this abstraction and allocation also. The purpose of the vSphere in the cloud is computing with the vSphere cloud computing is basically to hide the complexities of your physical resources from the consumer of those resources and provide a managed access to those resources on which VMs can run. Now, the providers of the cloud resource still benefit from all the operation and maintenance advantage of virtualizations, such as the cloud can be deployed as a private or community cloud, public cloud, or a hybrid cloud to serve the needs of one or more resource consumers in one or more legal business entities. So basically you see this one right here is a private cloud, which will basically be more internal. This right here, this public cloud, is basically a shared resource pool which several people on your WAN side can have access to that. And you got to look at that as your, I don't know if many of us heard of Live Drive. You've got Carbonite, and what they do is they virtualize this storage environment here in the public cloud, which is here. Private clouds are pools of resources dedicated to a single enterprise. These private clouds enable an internal management and deployment of VM or your virtual IT infrastructure services over the intranet in the enterprise and beyond the firewall. And the advantages of this is they provide self-service provisioning, elasticity of resources, they're rapid and simplified provisioning, they're secured, they improve the use of your IT resources, and you have better control of your IT budgets. A little bit more about your public clouds and their infrastructure. The public cloud service, the providers, they have many types of operations for multiple businesses, basically your IT operations. And looking at this slide is somewhat in the same way that the internet service providers can host websites for businesses. Cloud service providers host IT operations for multiple businesses. Typically, a public cloud is owned and operated by a third party. A VPN connection is also typically available. So using a public cloud can be perceived as an off-premise extension of a private enterprise. Companies using a public cloud receive all of the advantages that a private cloud offers, and a small company might be able to entirely outsource all of its IT by hosting this cloud services here as you see. Your IT assets are housed both internally on the customer premises and in the public clouds. And vSphere VMware vCloud Air is a secure, dedicated hybrid cloud platform that is built on the vSphere foundation. So it does the bridge, as you see here, between the public clouds and the private clouds, allowing access across both. It's basically used for disaster recovery, quick provisioning, data archiving, traffic overflow, offsite backup, development, testing, and there are just multiple things you can do with this. Your vCloud Air aids in the constructing and managing of your hybrid clouds. It also allows you to build a data center that is based on vSphere with a hybrid cloud built on VMware technologies and operated by VMware with your vCloud Air. You can use your extensive VMware ecosystem or certified vCloud partners worldwide. It supports existing workloads, third-party applications, and new application deployments. So this solution allows virtual machines to be migrated between private and public clouds without conversion. You should be able to meet the following objectives. You should be able to compare and contrast physical and virtual architectures, describe the benefits of using a VM, describe how vSphere interacts with CPUs, memory, networks, and storage, and describe how vSphere fits into the cloud and the software-defined data center.